Lecture 1b. In this lecture, we shall be dealing with the point of division of a straight line segment. We note that a point may divide a straight line segment either internally or externally. Consider two given points, point A and point B. And this is a line segment joining the 2 points A and B. Any point P on this line segment is called the internal point of division. Now let us consider another 2 points A and B. And this is a line segment joining the 2 points. Let this line segment AB be extended a little to the right. Any point on this extension is what we call the external point of division. That is, if this is a point Q on this extension, this point Q is referred to as the external point of division. Finding internal point of division. Let the point A x1 y1 and B x2 y2 be two given points. And let P with coordinate xy be a point that divides a line segment joining the 2 points internally in the ratio m:n. Then the x coordinate of the point P is given by x equal to mx2 plus nx1 all over m plus n, and the y coordinate is given by y equal to my2 plus ny1 all over m plus n. The proof of the formula is as follows. This is a line segment joining the two given points A and B, and let this be the point P on this line segment, and this point P divide the line segment internally in the ratio m:n. Now we construct two right angle triangles, one with side AP as hypotenuse and another one with side PB as hypotenuse. First, we draw a line through A. We draw a horizontal line through A and a vertical line through P. You can see these two lines meet at right angle at this point. We name that point C. Clearly, triangle APC is a right angle triangle with side AC x minus x1 and side PC y minus y1. Also, we draw a horizontal line through P and a vertical line through B. Again, the two lines meet at right angle at this point, and let us name that point Q. Triangle PBQ is a right angle triangle with side PQ x2 minus x and side BQ y2 minus y. Clearly, these two triangles, triangle APC is similar to triangle PBQ since they are equiangular. That's the corresponding angles are equal. And we know that if two triangles are similar, the ratio of their corresponding side must be equal. That is, AP over PB is equal to AC over PQ equals to PC all over BQ. That is, M over N is equal to x minus x1 all over x2 minus x equal to y minus y1 over y2 minus y. Now, to find the x coordinate of our point P, we have to consider this equation. Upon cross multiplication, we have m into x2 minus x equal to n into x minus x1. Opening the two brackets, we obtain mx2 minus mx equal to nx minus nx1. Bringing this term to the left and this term to the right, this will give us mx2 plus nx1 equal to m plus n in bracket then times x. Now to find x, we have to divide both sides of this equation by m plus n to get x equal to mx2 plus nx1 all over m plus n. Similarly, to find the y coordinate, we have to consider the equation m over n equal to y minus y1 all over y2 minus y. And solving for y, we obtain y equal to my2 plus ny1 all over m plus n. The midpoint formula. If pxy be the midpoint of the line segment joining the two given points a x1 y1 and b x2 y2, then m must be equal to n. Then x equals to x2 plus x1 all over 2 and y equals to y2 plus y1 all over 2. The proof of this is simple, is straightforward from the point of division formula. The proof: if p xy be the midpoint of the line segment joining the 2 points a x1 y1 and b x2 y2, then we know that m must be equal to n in the point of division formula. Putting m equals to n in the point of division formula, we have x equal to mx2 plus nx1 all over m plus n. When you put m equals to n here, this will give us nx2 plus nx1 all over 2n. When you factor n out, that n will cancel this n, giving us x2 plus x1 all over 2. Similarly, y equals to my2 plus ny1 all over m plus n. Again, putting m equals to n will give us ny2 plus ny1 all over 2n. Factoring n out, that n will cancel this one to give us y2 plus y1 all over 2. Example 1. Find a point dividing the line segment joining the 2 points a12 and b31 internally in the ratio 1 to 2. Solution. Here the two given points are x1 y1 equals to 1 2 and x2 y2 equals to 3 1, and the ratio m to n are m equals to 1 and n equals to 2. Now, to obtain the x coordinate of the point of division, we have x equals to mx2 plus nx1 all over m plus n. M is 1 times x2, which is 3, plus n is 2 times x1, and x1 is 1, all over 1 plus 2, which is 3. 1 times 3 is 3, plus 2 times 1, which is 2. 3 plus 2 is 5 over 3. Also, y equals to my2 plus ny1 all over m plus n, which is equal to m is 1 times y2 is 1 plus n is 2 times y1 is 2 all over m plus n, which is 3. 1 times 1 is 1, 2 times 2 is 4, 4 plus 1 is 5, then over 3. So therefore the point P that divides the line segment joining the 2 points internally is given by 5 3 5 3. Example 2. Find the length of the median AM of triangle ABC with vertices A 2 minus 3, B 3 5, and C minus 1 3. Solution. First, we draw First, we draw a triangle with the three given vertices A, B, and C. Now, the median of a triangle is a line drawn from a vertex to the midpoint of the opposite side. So to find the median AM of this triangle, we have to indicate the midpoint of BC and let that midpoint be M. Then the median is this line from A to M. First, we have to obtain the coordinate of the point M. Since M is the midpoint of the line segment joining B and C, so the x coordinate of that point, so the coordinate of that point M is x2 so the coordinate of the point M are 3 plus minus 1 over 2, 5 plus 3 over 2. So that will give us 3 plus minus 1 is 2 over 2, that is 1. 5 plus 3 is 8, 8 over 2 is 4. So the coordinate of this point is 1, 4. So we are now to find the distance from A to M. That's from the point 2 minus 3 to the point 1, 4. Using the distance formula, AM equal to the square root of x2 minus x1 squared, that is 1 minus 2 all squared, plus y2 minus y1 squared, that is 4 minus minus 3 squared. This is equal to the square root of 1 minus 2 is minus 1, and minus 1 squared is 1, plus 4 minus minus 3 is 4 plus 3, which is 7, and 7 squared is 49. 1 plus 49 is 50. So AM is equal to the square root of 50, which can be expressed as 5 root 2 units. Finding external point of division. Again, let AX1Y1 and BX2Y2 be two given points, and let PXY be a point that divides the line segment joining the 2 points externally in the ratio m:n. Then x then x equal to mx2 minus nx1 all over m minus n, and y equal to my2 minus ny1 all over m minus n. Please observe the difference between the external point of division formula and the internal point of division formula. In internal point, this sign, the minus sign here, was plus, while in external point it is minus. Let us prove the formula. Again, these are the two given points A and B, and this is a line segment joining the 2 points. If this line segment is extended to a point P, then this point P is the external point of division. So the ratio AP to BP is m to n. So from A to P is m, and from B to P is n. Again, we construct right angle triangles with sides AP as hypotenuse and BP as hypotenuse respectively. First, we draw a horizontal line through A and a vertical line through P. These two lines meet at right angle at this point. Clearly, the side AQ of this triangle is x minus x1, and the side PQ is y minus y1. Next, we draw a horizontal line through B to meet this vertical line at right angle at this point. We name that point C. Again, in this triangle, the side BC is x minus x2, while the side PC is y minus y2. Again, these two triangles, triangle APQ is similar to triangle BPC since they are equiangular. And we know that if two triangles are similar, the ratio of their corresponding sides must be equal. That is, AP over BP is equal to AQ over BC is equal to PQ over PC. And that is, M over N is equal to x minus x1 all over x minus x2 is equal to y minus y1 all over y minus y2. Now, to find the x coordinate of our point P, you have to solve this equation first. Upon cross multiplication, we have m into x minus x2 equal to n into x minus x1. Opening the two brackets, we have mx minus mx2 equal to nx minus nx1. Taking minus nx1, taking nx to the left and minus mx2 to the right, we have this: m minus n into x equal to mx2 minus nx1. Now, dividing both sides of this equation by m minus n, that will give us x equal to mx2 minus nx1 all over m minus n. Similarly, if we consider the equation m over n equal to y minus y1 all over y minus y2, we will obtain y to be equal to my2 minus ny1 all over m minus n. Example 3. Find a point dividing the line segment joining the point 2, 1 and 3, 1 externally in the ratio 1 to 2. Solution. Again, the two given points are x1 y1 equals to 2, 1 and x2 y2 equals to 3, 1. The ratio m to n are m equals to 1 and n equals to 2. Then, using the external point of division formula, we have x equals to mx2 minus nx1 all over m minus n, which is equal to m is 1 times x2 3 minus n2 times x1 2 all over m minus n. 1 minus 2, which is minus 1. 1 times 3 is 3. 2 times 2 is 4. 3 minus 4 is minus 1. Then minus 1 over minus 1 will give us 1. And y equals to my2 minus ny1 all over m minus n. And this is equal to m is 1 times y2 is 1 minus n2 times y1, which is 1, all over m minus n, which is minus 1. 1 times 1 is 1. 2 times 1 is 2. 1 minus 2 is minus 1. Minus 1 over minus 1 is plus 1. So therefore, the coordinate of our external point of division 1, 1.